All right, this is chapter 2.4, the complex number system. This is page 1. We'll see how much of this we can get through. How do you perform operations with complex numbers? So imaginary and complex numbers. We have the imaginary number I, which I think some of you are familiar with. I equals the square root of -1. We will frequently use the property of radicals, which is the square root of a times b equals the square root of a times the square root of b. Okay, we will use that, for example, when we're talking about like the square root of -5. We could rewrite the square root of -5 as the square root of 5 times the square root of -1 using the property of radicals. And since we know that the square root of -1 is I, we could write this as the square root of 5i. Stylistically, we would put the I in front, so this would be I times the square root of 5. Okay, but the idea is when we have these negative, where before we'd say, oh, you can't take the square root of a negative number, negative integer. Well, we can if we use imaginary numbers. Some things to remember here. Complex number system, a plus bi. We cannot combine those terms. All right, a is the real number. Real is a. And then b is imaginary number. Okay, and anyway, so we treat them kind of as a term, as a whole term, not a like term. When doing operations, we have to keep the real and the imaginary separate. So in this case, if we're adding or subtracting, we're just going to simply kind of distribute this negative in here. We would just rewrite this as 3 plus 6i minus 4 minus 2i. 3 minus 4 is -1. 6 minus 2 is plus 4i. Okay, so we combine the like terms. This would be very similar to if we had, if we were to write those out. If instead of I, if it were x or some variable, we treat it very much the same, except for when we start combining the i's, when we start multiplying the i's together. Like, for example, this next problem. So here we have the product. We're multiplying two complex numbers. So again, we would do that much like we would if we had, if x were a variable. We would just multiply these two factors together, combine all the like terms. We're going to do something very similar to that. We're just going to go, 3 times 4, right, is 12. And then we have 6i times 4. That's going to be 24i. And then you have 3 times 2i, so that's going to be plus 6i. And then lastly, you have 6i times 2i, right? Wait, this was supposed to be, that was 24, yeah, 6i. So you would have plus, so 6 times 2 is 12, and then I times I is I squared. All right, so that's this last term here. We multiply them together. Okay, let's start cleaning this up a little bit. We have 12 plus 30i. And then we have this, I didn't mention that part. We have this plus 12i squared. Well, if I equals the square root of -1, and if we were to take I and square it, that would be right, that would be square root of -1 times square root of -1. That would be the square root of -1 times -1, which would be the square root of 1, which would be 1. Oops, I did something wrong here because it's -1. Sorry, ignore all that. I squared would be the same. I is the square root of -1. So if we square this, we would square this. This cancels out. I equals -1. Sorry. Okay, I'm trying to speed through this during lunch. All right. Let's go back to our problem. This would be 12 plus 30i. And then, so since 12 times I squared Okay, that would be the same as 12 times negative 1, so that would be negative 12. So this is minus 12. Okay, so 12 minus 12, that cancels out, and that leaves us with 30i. And that is a complex number. Okay, it's kind of the same as saying 0 plus 30i, a plus bi. Okay, but we're not going to write 0 plus 30i because it's 0. We just write 30i. But it is a complex number. Okay. Oh. I think I've got all of 3 minutes here before the bell rings. So I'm going to try to just zip through these a bit. Okay. Number 1, pretty straightforward. 9 times 1 is 9 plus 2i minus, what's that, 72? No, 73i. Got it, basic math. And then minus 14i squared. So we have 9 plus 14. What am I doing? Why am I multiplying? Ignore all of that. I'm adding. Jeez. 9 plus 1. So it's 9 plus 2i plus 1 minus 7i. God, I'm just completely sorry about that, everybody. All of the person that's actually watched this video. So 9 plus 1 is 10, and then 2 minus this is negative 5i, and that's as simple as that. Okay, sorry, going too fast here. 6 minus 11i times 6 minus 11i. Okay, because we're squaring it. 36 minus 66i minus 66i. And then this is going to be plus 121i squared. 36 minus, what is this, 132i. And then this is going to be minus, since I squared equals negative 1, it's going to be minus 121. So it gives me negative 85 minus 132i. Okay, come over here. 3 times 2 is 6. Let's go 14i minus 12i, and then minus 28i squared. So 6 plus 2i, and this is going to be plus 28. 34 plus 2i. Again, this is 28 times negative 1, right? Because of that I squared. Okay, last two really quick. This one's silly. This would just be like saying negative 4 minus negative 4. Well, these two cancel out. That cancels out. So it just leaves me with negative 4. Okay. All it means is if we have the square root of negative 4 minus square root of negative 4, it cancels each other out. Okay. Last problem here. We're going to write this out. This would be the square root of 4, right? Square root of 16, square root of negative 1. This is the square root of 4 is 2, and this would be I, and this would be 4, and this would be I. So this would be 8I squared, and that would be 8 times -1, -8. Okay, since I squared equals